If you can explain linear regression but not multiple linear regression, interviews will expose that your ML understanding is incomplete. In the last video, you learned simple linear regression like one input, one weight, and one best fit line. But real AI prediction don't depend just on one factor. Imagine you're predicting a candidate's AI interview score. It's not only based on how many AI projects they build. It also depends on ML theory, Python skill, mock interviews, and communication. And that's where multiple linear regression comes in. Instead of one input, it uses many inputs together, and instead of learning one weight, it learns separate weight for every factor, like one weight for AI project, ML theory, Python skill, mock interviews. So it basically tells, like, one way tells how much AI project matter, one way tells how much ML theory matter. Now the model combines all of them to predict the final score. In simple linear regression, you saw the model finding the best fit line by reducing error. In multiple linear regression, the same idea continues, but now the model adjusts multiple weights together. It keeps changing all weights and bias until total error becomes minimum, as you can see. And that point is still the global minimum, but now it is finding the best combination of all weights. So this is the final takeaway we have, where in linear regression, we were only utilizing like one input to have that one best fit line, but in multiple linear regression we have multiple inputs and we utilize all of them to predict the final interview score. Now let's jump into the coding implementation. So first step, we imported the libraries, and the second step, we created simple data set. At this time the data is long. Then third step, we separated the input feature from the target features. Like the input features you already know: AI projects, ML theory, Python skill, mock interviews, communication. These are all the input feature, and the target feature we have is the interview score. So in the step 4, we split the data into training set and the test set. So why we do it? For 80% of data, we keep it for training, so that machine learning algorithm can build some understanding based on the data, and rest of the 20% data we have, we kept it for testing, like whatever the 80% data this machine learning model is trained on. Now let's check what understanding it has gained. So we test it on test data. So that's why we split the data in parts. 80% for training, 20% for testing. But this 80% 20% ratio is something you can decide on your own. Then in step 5, we train model on training data, as you can see. Then we finally fit it. And then step 6, we test the model on the unseen data, which we kept aside from our data set. Like when we done the split, like 80% for training and the 20% for testing. Now that 20% which was unseen data, which was kept aside for testing, now we'll test on it. And here are the results. As you can see, the actual score and the predicted score. So this prediction is made by machine learning algorithm after getting trained on that 80% data. And this is how it's performing. Now let's also check the weights and bias we have learned with those training. And then finally, let's check it on a new candidate score like AI project 6, ML theory 8, Python skill 8, mock interviews 5, communication 7. Now let's check it. What is going to be the prediction? His interview score, it is going to be 85.71. If you are learning AI randomly from Reels, you may understand overview of concept but still struggle to build job-ready projects. In my 11am class, I show the complete path from statistics, machine learning to MCP-based agentic AI projects. Join the class, link is in my bio.